Today's video is going to be on combinations. This again is in the probability chapter, but we're not really touching on probability itself just yet. When we talk about combinations in maths, selection is important, but order is not. And this is what makes it different from permutations. Before we get into word questions about combinations though, let's stop for a moment to look at NCR notation. We've come across this previously with binomial expansions, so you should remember that NCR can also be written as N and R in brackets. Let's remind ourselves how to evaluate NCR questions. Here's example 1. So here's an example, evaluate 7, choose 3. And of course we can use the NCR button on the calculator for this and just type in 7, choose 3 like this. So I put in 7 and then the NCR option is just directly above the divide button. So shift the divide button, you can see the C pops up on the screen and then 3 equals, and my answer is 35. But it's also good to know how it works. So let's look at that now. An NCR calculation is done as a fraction. On the top, I start at the n value, in this case that's 7. And I'm going to start multiplying down towards 1, but I'm only going to do 3 terms. And it's 3 terms because the R value is 3. On the bottom of the fraction, I'll start at 3 and I'll go the whole way to 1. So I should have the same number of terms on the top of the fraction as I do on the bottom. I can do a bit of cancelling out here to work this out. And my answer comes out as 35, just like we saw on the calculator a minute ago. So your turn now, evaluate 9, choose 2. Do it on the calculator first to make sure that you know how to use the buttons, and then work it out manually yourself and check and see if you get the same answer. Pause the video now and go ahead and do that. So this one's super easy. So in this case I've got 9 by 8 over 2 by 1, and the answer comes out as 36, which you should also get in the calculator by typing in 9, choose 2. My next example here is to evaluate 9, choose 7, and really you can do this yourself. So if you want to pause the video now and go ahead and work this out, and then play and see if you get the same answer as me. So in this case, I'm starting at 9, I'll put 7 values across the top. Note, by the way, that 7 by 6 by 5 down as far as 1 can be written as 7 factorial. But I want to show all my values for the time being, so I can just kind of cancel things down nice and easily. So I can do a good bit of cancelling here. The 7s will cancel, and so will the 6s, and the 5s, and the 4s, and the 3. And if I look at my calculation now, I can probably see a similarity to the previous question. I've ended up with 9 by 8 over 2 by 1. So again, I've got an answer of 36. And it's no coincidence that this is after happening, because if you look at the two questions, there's something interesting about them. Their R values add up to the N value, so 2 and 7 add up to the 9. And so whenever that happens, the two solutions will come out to be the same. And we can use this to our advantage because it means we can simplify what look like difficult long questions into much easier ones. So your question now is to evaluate 101, choose 99, but be clever about it. Don't use the calculator though. Okay, so the idea of writing down 101 by 98 other digits across the top is just ridiculous. So let's take 101, choose 99, and just change how it looks. So how else could I write this? 101 choose, well, 2 in this case, and again note that 99 and 2 make up that 101 on top. So it's much easier to work out now. 101 times 100 over 2 by 1, and it doesn't take much calculation to work out that my answer is 5050. I can summarise this neat little trick as n choose R equals n choose n minus R. In the word problems that follow, we're going to be using NCR calculations, and you can use your calculator for those. And let's look at an example now. Okay, so in example 3, I have 8 t-shirts and I need to pack 3. How many ways can I do this? So unlike our previous video on permutations, order isn't important here. When I pack the t-shirt, it's either in or it's not. And that's how I know that the question is a combinations question. So it's really straightforward to figure out how many ways I can do it. I simply evaluate 8, choose 3. And in this case, my answer is 56. So there's 56 ways in which I can pick 3 t-shirts from the 8 that I have. So in your question, I have 6 novels and I must pick 2. How many ways can I do this? So pause the video here for a second while you work that out. So my calculation this time is 6, choose 2, which is 15. Again, notice how in this question the order wasn't important. I either picked the book or I didn't. So I know that it's combinations. So this question is a little bit different because again, it's a selection question, so it's combinations, but I've got a bit of a restriction in it. I've got 7 friends, I can pick 3 to bring on holidays. My best friend has to come. So that's kind of one of my decisions made for me already. In how many ways can I make a choice? So I've got 7 friends and I have to pick 3, but my choice isn't actually as broad as that. I've already made a decision that my best friend is coming. So I really only have to choose from my remaining 6 friends, and I just have to pick 2 more people from that group of 6. So my calculation in this case is just 6 choose 2, and again that's 15. So I only calculate based on the choices that I have to make. The best friend wasn't a choice, she was definitely in. So here's a question for you now. There are 10 pizza toppings on the menu and I can pick 4. I love jalapenos, so I always pick them. In how many ways can I order my pizza? Pause the video here, give this a shot and then see how you've got on. Okay, so I start off with 10 toppings, having to pick 4, but I've already partly made my decision. Jalapenos are definitely in, so really I only have to think about the remaining 9 toppings and pick 3 from them. So my calculation will be 9 choose 3, and I can go to the calculator for this. So I've got 84 options. Sometimes there are choices that I don't want to make. So I'm back to the pizza. So let's go back to our pizza. There are 10 toppings and I can pick 4. I'm definitely picking jalapenos. I don't like anchovies on my pizza. In how many ways can I order my pizza so? Okay, so again, I've got 10 toppings. I need to pick 4. I've already decided on jalapenos. So that means I must pick 3 toppings from the remaining 9. But I don't like anchovies on the pizza. So I'm reducing my level of choice down to 8 toppings. But I still have to pick 3. I've picked my jalapenos. I need 3 more toppings. So I'm going to have 8 choose 3 as my calculation. I'll go to the calculator for that and I get an answer of 56. Okay, here's a question for you. So I'm going to get ice cream and there are 12 flavours available and I want 3 scoops and I'm definitely getting chocolate, but I hate bubblegum flavour. So in how many ways can I order my ice cream? Pause the video here, give this a shot and then play and see if you're right. Okay, so I have got 12 flavours available and I need to pick 3, but I've already made a decision about chocolate, it's in. So from the remaining 11 flavours, I only have to pick 2, but I'm not picking bubblegum because it's horrible. So I am really only down to 10 flavours and I'm going to pick chocolate and I still need to pick 2 more. So my calculation will be 10 choose 2 and the answer here is 45. Okay, so here's a further example. I have extra tickets to the Panto and I'm going to bring 2 adults, 3 nieces and 3 nephews, and I can pick from 6 adults, 4 nieces and 5 nephews. How many groups can I bring? So I've got a number of different choices that I want to make here. I want to bring some adults and I want to bring some nieces. And you may remember from our previous video on permutations when we looked at the fundamental principle of counting, if I have m ways for doing one thing and n ways for doing another, then I've got m times n ways of doing them together. So if I see the word and popping up, basically, it's an indication that I'm going to want to multiply. So I'm going to do a calculation for the adults, for the nieces, for the nephews, and then multiply them all together. So you should be able to do this. So pause the video here, try it, and then play and see if you're right. So here are my 3 calculations. 6 choose 2 times 4 choose 3 times 5 choose 3. And when I work this out, my answer is 600. So I've got 600 different groups that I can select from that bigger group. So here's question 6 for you. So your question is that 4 people audition for the lead in the school play, 8 audition for the second part, and 15 people audition for the chorus, which has 6 parts. In how many ways can the roles be filled? So pause the video here, try the question, and then play and see if you're right. So we got to think about the lead, the second part, and the chorus. For the lead, 4 people audition, but I can only pick 1, so that's 4 choose 1. 8 people go for the second part, but again, I can only choose 1. And 15 people go for 6 places in the chorus. So I've got 15 people to pick from and I have to pick 6 of them. And I need a lead and a second and the chorus. So I'm multiplying. And this time I get a really huge number of 160,160.